Yeah. Right, so diagram ta copy করে নাও আমি জিনিসটা আবার বুঝাচ্ছি একবার Right, so what you have here is a transverse wave that's moving forwards, and you need to know which way the particles are moving, right? So basically that's the idea. So এখানে আইডিয়াটা হচ্ছে যে whenever you want to trace the path, the first one, to find the future position of the particles on a wave, we trace the particles onto the future wave. Future wave মানে হচ্ছে do you see that light gray color there? That is the previous wave. And this one here is like the future wave. So wave ta ki hocche oke translate kore samne jacche as the future location. So you need to find out where the particle is moving as the wave moves forward. So you basically draw the future version and see where does your particle or what does your particle need to do to be on this future version. And that's how you get your answer.
Can you explain
F, right. F এখানে yeah so previous wave টা যদি দেখো that light gray color is the previous wave ওইখানে E যেটা F এর সামনে isn't it at the bottom আর জিনিসগুলো সিকোয়েন্স এ হয় like if somebody is already at the trough for me next আমি trough এ যাব তারপরে আমার পরের জন যাবে so it's a sequence that's happening so E is already at the bottom আর উপরে ওঠা স্টার্ট করলো F তো এখনো বটম রিচ করে নাই F তার জন্য আগে বটমে যাবে তারপর উপরে ওঠা স্টার্ট করবে so right now at this instance F is moving downwards. Right, so দেখে নাও আজকে আমরা longitudinal wave করব and I will also show you intensity which is like a very small topic আজকের মধ্যে হয়ে যাবে so just make sure you copy this or you understand this. Can anyone remind me what was the second diagram for যে এটা কি represent করতেছে এখানে yeah এটা হচ্ছে particle movement half a wave later. Goes next to page 30. Page 30 পাশে এটা Can you explain the particle in the middle of the wave? Does it depend on the direction of the wave goes? Yeah. So see a particle here, এটা কেন হচ্ছে উপরে যাবে তারপর নিচে যাবে because at this instant here it went up, right? And half a wave later it came back to the center. So if something went up and then came back to the center, what is its motion? Up and then down. That's what's here. Stationary is a wrong answer. It can't be stationary, right? Your particle is oscillating. I don't think there's a brief way of putting that topic, but I'll try. Young's double-slit interference experiment is like a chapter full. So yeah, I'll try to show. And the other one is diffraction grating.
I did not understand how your equations came.
Which equation? D sine theta n lambda? That you don't need to know. But there's another equation, which is lambda equals to AS by D. That you need to know. There's a derivation for that using similar triangles. ওটা আমাদের কিন্তু সিলেবাসে জিজ্ঞেস করে না but though it's given in the textbook that's why I show it but I've never seen them as derivations in AS. Derivations will mostly থাকে for A2. So plus the one that we are learning, the double-slit interference experiment, uses a higher level of math knowledge. It's called small angle approximation. Small angle approximation I don't think is in your AS math. I don't think there's a chance of this showing up. It's there in the book, right? But I don't think it আসবে mostly যেটা আসে there's something called manual method. If you want to find a wavelength from double-slit interference experiment, there's a manual method মানে হচ্ছে ম্যাথ করে বের করতে হয় ওইটা লাগে আর ওইটার জন্য you need to have some basic idea of the derivative. But diffraction gradient at formula D sine theta equals to n lambda for the derivation. Yeah, halfway the wave was here, right? So and it starts to move forward. The wave says it starts to move forward. It goes like that. It goes like that, and then reaches this point here. So all the particles now have to be on the wave. Wasn't the particle here at the bottom? So which would move right down to the top? Wasn't the particle at the top? Then move to the down, right? And you find that particle remains here, but it can't remain stay here, right? So it did something. So it went down and up. You gave me over with gray wave. I think the one I showed was this wave. This is the new wave. Okay. So if this is a new wave for your particle, you the new wave, where does it move? Down. And for the down particle, the new wave, where does it move? Up. Now this particle that was center is that particle on the right, which when it start moving at the start, up, and now is back here. So what is this motion? Yep. Up, and then down. Up and down visible. Yeah, because up and down not tell you the sequence. Do you have stationary waves in your school exam? No stationary waves. Just superposition.
But it did not stationary waves in class, even though it did not.
Achha. Yeah, এগুলা আমরা বের করছি কেমনে we know the gray wave here is the original wave মানে এটা, and this black wave here is the new position. So for the particles on the gray wave to be on the black wave, which way do they need to move? Up, right? And যেটা হচ্ছে এখানে has to move down. So that's how we trace their future location. না সামনেই যাচ্ছে, আমি লেবেল করে দিই, কনফিউশনটা কম হবে। এই গ্রে ওয়েভটা হচ্ছে the original wave মানে যেটা আগে ছিল, and this here is the future wave. Behind ঠিক করে দিচ্ছি। আচ্ছা, so পিছে ছিল। Done সবার? Wave propagation is in simple terms wave movement. Did I make you hear train, pulse, and continuous last class? All right, so longitudinal wave আগে একটা জিনিস দেখাইনি, then I'll start longitudinal wave. I'll show these together. Right, সবাই একটু স্ক্রিনে, so let me explain what's going on here. এটার জন্য হচ্ছে you can use page 31, but I feel page 31 we don't have enough space. I'll just explain the work in here. Pashi will do the math. Right, so সবাই স্ক্রিনে কিছু লেখো না। This is plenty in your past paper, and you'll find this in your measurements chapter. So আমরা যখন measurements chapter করছি in the first chapter, ওটা MCQ যদি notice করো, you'll find that 50% of them are like CR screens, Okay, but back then I couldn't really teach you guys because we need wave knowledge for it. Okay, so ওরা হচ্ছে measurements in normally জিজ্ঞেস করে first 3 questions এর মধ্যে. So what is this device? It's called a CRO, cathode ray oscilloscope, right? And it was there in your O levels. But O levels এর problem টা কি? It was in varying degrees. মানে হচ্ছে IGCSE students, you had it just basic version টা. GC students are too extreme ছিল. And in the old GC syllabus, it was even more extreme. Like you needed to know what the parts and plates were inside. So if you remember your O-level question paper, there were some question papers with plates in them. X plate, Y plate. That's basically what happens in the CRO. The CRO ভিতরে কি function হয় ওইটা নিয়ে question ছিল, which is useless because a device ভিতরে কি হচ্ছে doesn't really you don't need to know it. I mean, it's like whatever your voltmeter, right? You know how to use a voltmeter. Do you know what's inside it? No, right? So no one needs to know. So এটা ওরা বাদ দিয়ে দিছে. Thankfully, we never need to know as well. So এখন we need to know something else though, which is reading the CRO. So CRO তে cathode ray oscilloscope কি হয় আমি একটু explain করি, okay? So before we start, since you had this in your O levels, can you tell me what is a CRO? Cathode ray oscilloscope or oscilloscope বলা হয়, but what is it actually? Right, very good. So it converts waves to be displayed visually. Sorry, longitudinal waves to transverse wave. Achha, okay, fine. Is there any other use of CROs that you know of? কোথায় use করা হয়? Right, your AC supply. If you want to see how your AC supply looks like, right? What do you use? CRO, right? আর কোনো use? Yes, very good. Hospitals হচ্ছে ওই যে pulse measure করার জন্য যে device থাকে, right? That's the CRO. It's called an oscilloscope. So the correct answer to the question though, a CRO is actually a voltmeter. It's a visual voltmeter. Okay, so if I take this and I make this my voltmeter here, right? It shows me voltage and it gives me a value of voltage. But what if the voltage is fluctuating? What if the voltage is going up and down, right? This device won't be able to show this like my voltmeter, right? Because the fluctuations typically take place 50 times every second. It'll be so fast that a device can't even register it. So device ভিতরে একটা meter মতন থাকে that tries to move when there is a fluctuation. And if it happens 50 times every second, before it can move, it has to go back again. So eventually what does it do? It gets stuck. It just vibrate in one location, right? So I can't really read the wave. I want to read the wave. Okay, when I want to see the wave. So what we do is we take our CRO and we connect it to whatever voltage is generated anywhere. So if I take my CRO and connect it to a person's body, the person's body generates voltages as the heart beats. So to show it. If I want to see an AC supply, right, I take the voltmeter or the CRO and I connect it to the terminals of my home. It'll show me the graph, right? Similarly, I can also convert any physical quantity into a visual representation. How? Through a sensor. So what's a sensor? A sensor is an electrical component that takes in a sensing input, output. Yeah, it's like a physical quantity like pressure, density, তারপর হচ্ছে vibration, sound, এইসব কিছুকে নিয়ে কিসে convert করে electricity. So microphone work in which you had in your O levels, key basic principle use করা হতো. So there used to be a diaphragm, like a very thin flap, and as sound went through it, right, this thin flap would move like that because of vibration, and there was magnets around it. So as this thing moved, the magnetic field lines were cut by this thing. As this thing cut the magnetic field lines, what was induced in your microphone? A voltage. And you're looking at the voltage here. So the thing that a CRO is capable of doing is take in waves, any form of waves, by the way, it doesn't need to be longitudinal wave, and it can convert the longitudinal wave into a what wave? Yeah, but it is not really converting it into a transverse wave. What it actually does is it's basically just giving you energy variations, and those energy variations can reveal to us the vibration. So as this longitudinal wave, by the way, do you know longitudinal waves have parallel vibration to the direction of wave propagation, right? From lines they draw kora hoy. So as the wave passes through here, the microphone vibrates and it creates a voltage, and that voltage is what we see on the screen. And that voltage allows us to find what? Frequency, because the rate at which the microphone oscillates is the same rate at which the sound vibrated as well. So that's how the frequency is found. And the y-axis gives you what here? This is the part that you have to be careful of. The y-axis is actually a watt axis, a voltage axis. Acha, so the y-axis provides you voltage and the x-axis provides you time. Clear about this? Now, how do we read a CRO? On a CRO, the wave read kemne kora jay. So if you want to read what's on the CRO, let me show you. Right, look at this. So I've taken like a sound and I have passed it over a CRO. CRO to pass column, and this is what the wave looks like. Can you differentiate the wave here clearly? Can you tell me what makes one wave? No, right? Why? What's the reason? Yeah, the problem is it's too dense. There are too many waves out there. Some of the waves that you see here, they're smaller than my division out there. So I can't read it. It's like a graphic division. The information is within the division. Will you be able to make readings from there? No, right? Because it's not precise enough, right? So there's like a wave ashlo. What can I do here? I mean, CROs are expensive. So it's not like you can buy another version with a different setting, right? So what do you do here? So it turns out CRO, there's this whole list of settings out there. In fact, if I show you like a real version, it'll be too overwhelming, because if you look at the settings out there, cathode ray oscilloscope bullet, okay? Do you know what a cathode ray is? Oh, you don't have it in chemistry anymore? Cathode rays? That's okay. I don't know what this is. Sorry, electronics. Yes. Apparently someone's name's CRO. Okay, anyway, so what you see here is your CRO, okay? Do you see the number of knobs out there? So সবগুলো function আছে, আমাদের কোনটা লাগবে না। আমরা কাজ করব হচ্ছে যে এইটা দিয়ে, this one. And do you see what's written at the top there? Time / division. What does that mean? The time represented by each division on the screen. আর এই যে এটা নিয়ে কাজ করব, এখানে there's one, what does it say? Voltage per division. তারপর এখানে there's like hold, তারপর hold মানে হচ্ছে তোমার স্ক্রিনে টাটকে থাকবে, এটা হচ্ছে x axis y axis shift করা যায়, levels check করা যায়, and the input goes here. যে দুটো হচ্ছে তোমাদের input থাকে, and এখানে আর কিছু আমাদের কি লাগবে না, আমাদের আর কিছু লাগবে না. So yeah, just see what this is. Now এটার screen data, that's what our focus is on, the screen, right? So this screen is the one I've been showing you, this one, right? So how do I make my wave appear like one wave or two wave cycle, right? So see what we need to do here. Amra jeta first korbo, we'll change the time base setting. So right now the time base setting gives you how much? 5 milliseconds, right? What does that even mean? Every box on your screen is 5 milliseconds, right? Buchho jinishta ki mean for every division, like smallest division is 5 milliseconds. But isn't the wave smaller than that? What does that mean? Is the time period of the wave more than 5 milliseconds or less than 5 milliseconds? Less, obviously, right? তার জন্য ভিতরে চলে গেল। So আমি যেটা করব, আমি তো আমার wave কে চেঞ্জ করতে চাই না। আমি rather কি চেঞ্জ করব? Divisional size. And the time base allows you to do that. So আমি 5 থেকে যদি 2 যাই, am I now not more closer to my frequency or time period of my wave? When I 5 ছিল না, okay, so you said it was less, right? Don't I need to lower my value? So as I lower my value, it's okay. I mean, you can see some waves out there, but it's still not the best. Ideally, you need to have like one wave or two waves on the screen. So if we do trial and error, you'll start to notice, now we have one wave maybe, but there's a problem still remaining here. What is that? Yeah, the top and the bottom got cut off. And that is because of a problem in which axis? Y-axis, right? So y-axis set korte hobe. So y-axis ami jodi 10 dei, now you have the whole wave on the screen. Okay, so আমি হচ্ছে একটু শিফট করে নিই তোমাদের জন্য। Yeah, so if you look here, can you tell me what is the frequency of this wave? Ekটু try করো তো, এটা O levels এ ছিল, so frequency বের করো, or O levels এ না থাকলেও, আচ্ছা I think যখনই বলি O levels এ থাকে you assume you forgot. So আমি বলি কি হচ্ছে এখানে, tell me how many boxes, right? small boxes make one wave? Count them. How many small boxes make one wave? 4. No, small boxes. Sorry, I should have said a different word. Small division, like these divisions. Those. So how many? How much? 18.9. That's very precise. So, Ajay, this is 1, 2, 3, 4, 5. So 5, 10, 15. This would have been 20. So if each is 1, so 15, 16, 17, 18, 19, 18.5. I mean, by the way, exam diagrams are very precise. Okay, but they'll give you like perfectly passing through a proper point, not like this. Right, so 18.5 boxes make one wave. What is the frequency? 1 by? Our repeat query. What is the time period? Tell me what the time period is. Is it 18.5 or is it something else? Yes, what is it? Yes, very good. So this 500 microsecond is what each division represents. I have 18.5 divisions where each division is 500 microseconds. So what is the total time here? Yeah, 18.5 into 500 microseconds. Do you understand? And that's your what? Time period. And then to find your frequency, what do? 1 by time period. Do you understand this? 3 marks there, okay? I feel like there's a lot of marks available here. If you know what to do, easy marks. Okay. So yeah, that is my CRO. So this is the diagram here. Okay, so এটা কি হবে আমাকে একটু পুরোটা বলো. So I've given you one version. So this is find me the frequency. Try this. This is the math, okay? Find the frequency for me and find the amplitude. Amplitude তো usually হচ্ছে এটাতে হয় meters এ. এখানে আমরা amplitude বের করি in terms of voltage. It's on the screen. Amplitude is 4 volts or centimeters. No, amplitude should be in voltage. হচ্ছে না হ্যাঁ হ্যাঁ these are all seconds. Amplitude is 4. No, amplitude 4 na. 1.25. Frequency 5. 5 or 0.5. 5. That's okay. 1.1. How do you get that number? Anyways, there's major confusion going on here right now. Let's try to clarify. So what we have here is your wave, right? So can you tell me what is the number of boxes needed to make one wave? 8, right? Oh, 9 can I say? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 boxes, and each box represents what time? So you can a point per oita. So how much is it? 0.1. So this 8 into 0.1, which is 0.8 seconds, is my what? Time period. So therefore, if I want to find frequency, that is 1 by 0.8. That is how much? 1.25 hertz. আচ্ছা, যাদের অন্য অ্যান্সার আসছে explain to me কি করছো? 9. আচ্ছা, and 5 আসছে কেমনে? Oh, you took another wave. Oh, it's a blue wave. That's yeah, a blue wave will answer right. Wait, blue wave কত আসছে তোমার? 5. No, I think blue wave টা দেখে নিতে হবে। Blue 5 আসার কথা না। The whole thing is the blue wave, right? So 8, 9, 10, 20. So 20 into 0.1, that is 2. Half আসবে। Right? Are you clear? Okay. And what is our amplitude here? Amplitude easy. How many boxes make the amplitude 4? And how much does each box represent? 20. So 80 volt is the amplitude. এখানে amplitude টা আমরা usually use করি only for comparative purpose because এখানে absolute value পাওয়া যায় না. Amplitude is not a voltage. Amplitude is what? A displacement, right? Our device doesn't show a displacement. What does it show? Voltage. So I can't really tell you what the amplitude of this sound is. However, if this sound is 80 volts, আর আরেকটা যদি sound আসে of the same type that is 20 volts, I can say that the other sound is what? Quieter. 80 থেকে 20 মানে loudness কমে যাচ্ছে, right? So it's a comparative measure. It's not an absolute measure. Okay. Right. So that's your CRO. এখানে আমাদের এখন কি টাইপের কোয়েশ্চেন নিয়ে কাজ করতে হবে এটা একটু দেখাবো। সো এটার পাশের পেজে একটা গ্রাফ ড্র করতে হবে। ওকে, এটা আই গেস ড্র করতে পারবো না এখন, বাট আপলোড করে দেবো। এই পাশের পেজে একটা গ্রাফ দেখো। Why did I multiply 0.1? Because that's the size of each division. It was from the knob that was placed at the bottom. আচ্ছা, সিআরও স্ক্রিনে কি টাইপের জিনিস আসে? সো লেটস সি। আমাদের এই টিপিক্যাল ওয়েজ গুলো তোমাদের সিলেবাসে খুব কম দেয়। What they give rather is some very random shapes. So screen কিছু লেখো না। This is the one I'm going to draw right now. Explain to me, what is this? Half a wave, okay. Acha, anything else? What is this? Amplitude would be the measure of the height, but what is this? Half a wave. Acha, does it have any preceding or succeeding wave? Aage piche kichu ache? Nah, right? So it's just this shape out there, right? Yeah, it's a pulse. Pulse বলছিলাম তোমাদেরকে the single waveform, right? I drew this like this তার জন্য half a wave মনে হচ্ছে, but তোমাদের এক্সামে কি দেয়? তোমাদের এক্সামে কি দেয়? এরকম। That's a pulse as well. That's like a key tone on a piano. Just একটা key tone যেটা এরকম হচ্ছে size আসে একটা, okay? So pulse কি shape-এর হয়? Any shape. But the idea is that it is a wave generation, okay? It didn't just complete a whole wave, just it took, okay? So that's a pulse. এখন No. I gave an example with a complete wave, but pulse such a one single vibration. It doesn't need to be a single wave. And ওইটা just লেখে থাকবে is a complete wave, right? That's not wrong. It has a complete wave. এই ওয়েভটা দেখতে এরকম। You get what I'm trying to say? মানে a single transverse wave would have up and down, but a single non-transverse wave is just up, and that's it. That's the whole wave. এটা আর কোনো অন্য কিছু নাই। ওয়েভের তো আইডিয়া হচ্ছে it's a vibration. It's not a vibration up and down. It just উপরে গিয়ে নিচে নামলো না, that's a transverse wave. It just didn't complete the other part. So the idea is that any repetitive shape is what we call a pulse. It will repeat অনেকবার হতে পারে, okay? So a sine curve মানে যে sorry yeah, that's a pulse. Yep, just one isolated segment is a pulse. It could be anything. Yeah, that'll be that's not a pulse. That's a train. And if it doesn't start, it doesn't stop, that's continuous. Okay? Acha, anyways, আমি বুঝাই নিয়ে বাকি পার্টটা তাহলে তোমার একটু ইজিয়ার হবে। তোমাদের যেটা করতে হবে এই স্ক্রিনে এই পার্টটা ঝামেলার, ওকে? And I don't know why they still teach this. মানে এটার কোনো background নাই. They just randomly drop this in your syllabus, okay? So you have a pulse that's been sent. Can you give me an example of a scenario where we send pulses? Sonar, very good. It's using something called echolocation. Sound send করা হয়, soundটা bounce করে back করে, and you try to see how much time it took and that will allow you to find out what the distance is, right? So a pulse was sent, and the pulse went on, and then few seconds later, this was achieved. তোমার এই shapeটা দ্বারা that. So isn't it the same shape as the pulse? But what is it lacking here? Yeah, the amplitude, right? So does that mean it's the same energy or lower energy? Right. So ওরা কি question জিজ্ঞেস করে যে you send the pulse came back. This is the diagram. What is the time interval between sending the pulse and receiving the pulse? That's number one question. Our question is what's the pulse duration? Our question is what's the pulse length? And unfortunately, they all seem the same thing. They sound very similar. So we can clarify the time between the two pulses is the pulse interval. Okay, pulse interval when it's something it came back as the interval when you send it and receive it. That's called pulse interval. If I use my pulse interval to find distance, right? Like yeah, this is double the distance. Double the distance. Do you understand? Because it goes and comes back. This length that you see here, though, it is on the base here. This is what we refer as pulse duration. How long was the pulse active when the pulse is time period? Okay, so this is exactly the time period of your pulse. Time period of this is part of the oscillation. So this is pulse duration. Our quantity is this time axis or a pulse is the x-axis distance. So what does this give us? That is what we refer as pulse length. Pulse length. What is the size of your pulse? Okay. So this would be in terms of centimeter, and we're talking in terms of seconds. And pulse interval is this. Now my question is why we need to know this. What's the point in it? Okay. So look at this problem. If I do this in real life and I use a diagram like this, where I have a pulse that's like that. That's the pulse. And the reflection is this. Can you tell me what's the issue here? What's your first to my pulse, second term or reflection? When you investigate this is not really convenient. What's the problem here?
I receive the pulse as I was.
Yes, you received the reflection while the original pulse was still on. Do you see there's an overlapping part there? এইটাকে বলা হয় swamping. Swamping জিনিসটা কি তোমার যে ডিভাইসটা সাউন্ড প্রডিউস করে ও প্রডিউস করার পরে ওই রিসিভ করে. There's a name for that device. It's called transducer. On the A to the last chapter শিখি. So it's basically a device that can send sound and receive sound. It's used in ultrasonography. They have this machine that they put on your body. They put some gel and then they do an ultrasonography. These are all in our syllabus, by the way. So we ultrasonography করার সময় যেটা হয়, your pulses are going and they're coming back. So if your transducer, the device, it can receive or send. It can do both together. So when it's sending, isn't the pulse already back? So it can't receive that. So eventually the machine can't figure out is it going out or is it coming in, and causes an issue. So এখানে কি দরকার ছিল আমার pulse duration-টা চেঞ্জ করা দরকার ছিল নাকি pulse interval-টা চেঞ্জ করা দরকার ছিল? Okay, so the correct answer is interval কিছু করার থাকে না. কেন কি? I'm trying to find the depth of something. আমি depth change করার তো scope নেই আমার. So আমাকে change করতে হবে something that's in my control. What's in my control? Duration, right? So আমি কি করব? এটাকে যদি ছোট করে দিই আর এটা রিফ্লেকশনটা কি রকম দেখতে হবে? Same. Wouldn't they then spread out, and wouldn't there be a gap between them? Right? So the aim is whenever we want to use these kind of scenarios, we need to make sure our pulses don't overlap. এটা করার দুইটা ওয়ে আছে. Either you can increase the duration decrease the duration. Or you can increase the interval. Usually interval increases scope থাকে না. You're trying to find that place, right? But যদি চেঞ্জ করতেই পারো তুমি তাহলে তো ফাইন্ড করার কিছু নাই. আর তুমি যদি ডিউরেশনটা চেঞ্জ করতে পারো, that's better. আরেকটা জিনিস বলে নেই, এটা actually visually দেখানো একটু ডিফিকাল্ট হবে. I'll try to explain. Do you know parking assist গাড়িতে থাকে? So গাড়িতে parking assist কি একটু বলি. Some cars have it. So as you are parking back into a wall, right? Camera থাকে সামনে. I mean, you can see on your car, but you'll find that some cars make noise as you're backing up. Not that annoying noise that continuously হতে থাকে. আচ্ছা, যে reverse দিলে, there's basically a beep sound, and the closer and closer you get, what does the beep start to become? More frequent. Okay, so a beep sound frequent হইতে 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 একটা পয়েন্টে যে গাড়ি নিজে থেকে থেমে যায়. So it's basically parking assist. What do they use to figure out where the wall is? Sound. আচ্ছা, which sound? Ultrasound. Because তোমার যদি audible sound হয় তাহলে তো হচ্ছে it's first of all disturbing. There's always a car making a sound going back, right? Art হচ্ছে it will be confused with background noises, মানে random noises around you. So it goes into which scale? Ultrasound, right? But the ultrasound problem is the ultrasound is a wavelength আছে. And at the point when you go very close, the pulse can't even move out of your source before it has to what again? Come back. So এই জায়গাটা কি আটকে যাচ্ছে না? So there's a limiting factor to how far your sound can travel. It must be equal to or less than the gap you're trying to find out. I'll give you a better example. Let's summarize it. This is my car feature part and this is my wall. What if the wave looks something like this? The back of the car. Just a couple of minutes away to take it out too. So this is the back of the car here. And this is the wall here. And the sound that comes out from here is like this. Like the wave size. Isn't that very big? Isn't it bigger than the gap that we have? The sound তো যেতেই পারতেছে না পুরোপুরি, রিফ্লেক্ট করে ব্যাক করা তো দূরের কথা। সো এখানে রিফ্লেকশনটা কি উল্টাপাল্টা হয়ে যায়। And if you have done wave chapter, there's something called destructive interference. When two waves overlap, they cancel each other out. ওইটা হয়, eventually কিছুই শোনা যায় না। So you need to make sure whatever wave you're sending has to be big enough to fit in the gap that you're trying to send to. Okay, so এটার জন্য আমরা কোনটা নিয়ে কাজ করি? Which property? Like to ensure this particular behavior, pulse length. Pulse length আমার হইতে হবে smaller than the gap I'm trying to work with. If my pulse length is bigger than the gap I'm trying to work with, wave তো বেরি হতে পারতেছে না পুরোপুরি. Okay, so yeah, these are certain limitations out there. এটা নোটস গুলো দিব আমি, and next class we'll move on to our next topic. Oh, হ্যাঁ, তুমি both started করে দিব.